So now that we've looked at multiplying and dividing by fractions, let's look at doing some addition and subtraction with the fractions. So I'll start with a pretty simple example. 3/5 divided by 2/5. With addition and subtraction of fractions, the main thing we want to look for is that both fractions have the same number for their denominator. We call this having a common denominator. If they have a common denominator, then the process becomes relatively easy. If I'm going to take 3/5 minus 2/5, the denominator will stay the same. It'll stay as a 5. But we'll actually do the arithmetic with the numerator. So 3 minus 2, so in this case 1, and I just end up getting 1/5. This is the main thing to remember. If we have common denominators, then we just have to do the arithmetic with the numerators, and then the denominator will stay the same. So for another example, it works the same way with addition, something like 7/4 plus 5/4. Again, I have common denominators, so that means when I add these together, my denominator is going to stay the same, and then I just add 7 plus 5, so I'll get 12 in the numerator. And so I end up with 12/4, or just 3. Now the problem, of course, comes with what happens when you start with two fractions that don't have the same denominator, that don't have common denominators. Well, let's look at an example of that, something like 3/7 plus 4/5. In this case, before I can actually add these fractions together, I need to make it so that they have common denominators. So what we'll do is we'll look at the two denominators we have, and we'll decide on a common denominator. It doesn't have to be a particular one. Usually we pick the smallest one, but you don't have to necessarily. So I'm going to pick a number that is a multiple of 7 and it's a multiple of 5. In this case, I'm thinking 35 is probably a good number. So now I need to convert both of these fractions so that they have a common denominator of 35. Well, how do I do this? I'll do this by multiplying each of these fractions times another fraction that actually doesn't change the fraction. So in this case, in order to get a 35 in the numerator, I should multiply to get a 35 in the denominator, I should multiply it by 5, right? 7 times 5 is 35. However, to make sure that I don't change the value of the fraction, I have to also multiply the numerator by 5. Essentially, when I multiply 3/7 by 5/5, since 5 divided by 5 is equal to 1, I'm not changing the value of this fraction, because if I multiply anything times 1, it doesn't change the value of that number. So technically, I'm multiplying 3/7 by 5/5, but it's really not changing the value of the fraction because we're just multiplying by 1. And so what we'll end up getting is 3 times 5 is 15, and then 7 times 5 is 35. And sure enough, if you reduce this back down, if you reduce 15/35 back down to its smallest part, you'll get 3/7. So we have the same value of the fraction. Now for the second fraction, again, I'm trying to get 35 in the denominator, so I need to multiply that 5 by a 7. But again, I can't just multiply the fraction by a 7 just because I want to. I need to multiply the entire fraction by 1, so I'll multiply it by 7 divided by 7. And in this case, I'll get 4/5 times 7/7. This will be 28/35. So now at this point I have common denominators, and I can just do my regular fraction addition. So I'm just going to add 15 plus 28, so we'll get 43. And then my 35 stays the same. So 3/7 plus 4/5 will get 43/35. Let's try a different one. So another one from the notes, 5/6 divided by 3/8. Again, I'm going to try to find a common denominator that will work for both of these fractions. Now obviously if you multiply these two guys together, you'll always get a common denominator, so 6 times 8 is 48. But that's not necessarily the smallest one. In this case, I could actually do 24, because 24 is a multiple of 6. 6 times 4 is 24. And it's also a multiple of 8, because 8 times 3 is 24. Now again, you can use whatever common denominator you like, but usually if you can keep the numbers smaller, it helps you with the arithmetic. You're less likely to make a mistake as you go along. So in order to change a 6 to a 24, I need to multiply that number times 4. But again, I can't just multiply the denominator by 4, I need to also multiply the numerator by 4. And then to change the 8 to a 24, I'll need to multiply that times 3. 3 times 8 is 24. And then of course I need to multiply the numerator as well. So I'll multiply that by 3 over 3. So I'm going to convert 5 over 6 into 20 over 24. And then I'll convert 3 over 8 into 9 over 24. And again, if you take these two fractions and simplify them back down, you'll get back to 5, 6, and 3/8. So we haven't changed the value, we've just changed the way that the numbers have looked. We've scaled them to some different multiples. So now since I have common denominators, I can just say 20 minus 9 for the numerator, so that will be 11. And then in the denominator will remain with 24. That'll be a good answer for us. I should mention one more thing before we move on. Just like with the division, you might find yourself with a fraction and a whole number. So how do we deal with something like that? For example, if I have 3/5 plus 6. In this case, if I want to actually combine these into one fraction, I could easily say this is 6 3/5, of course. But if I just want to do this as fraction addition, I can actually again just think of this 6 as being 6 over 1. And now I'm back to the same problems that I was working on before. In this case, I actually don't need to convert both of the fractions because I know that I can change the 1 to a 5 really easy. So I can actually leave the fraction on the left as just a 3/5. But I can multiply this 6 over 1 by 5 over 5. And that will give me 30 over 5. And now I do have common denominators, but I only had to change one of the fractions. So if you don't have to change both of the fractions, don't go through that process. The more steps you do, the more likely you are to make some kind of arithmetic mistake. So the fewer steps you can take, usually the better. So in this case, we have 3 over 5 plus 30 over 5. So this will be 33 over 5.